The figure shows the graph of a function f. The zero and extrema for f are labeled, and the point of inflection of the graph f is labeled. Let a, b, c, d, and e represent the x-coordinates at those points. Of the following, on which interval is f increasing and the graph of f concave down? So these are the points of inflection, 0 and extrema, and we need to find which portion of the graph is increasing, meaning that the slope is positive, and the portions of the graph that is also concave down, which means the second derivative is less than 0. And it just means the graph is like a upside down U-shaped. And increasing just means that the slope on that region of the graph is positive. Okay, so if we look at the graph, we see that there are two regions where the slopes are positive. The slopes are positive here from A to B. They are negative from B to D, and positive again from D to E. If you draw some tangent lines, you'll see the slopes at those intervals. At B and D here, the slope, the tangent, is 0. Okay, so AB and DE are increasing. Now we need to find out which one of these has a concave down. So concave down means the second derivative is 0, meaning that the tangent lines, the slope of the tangent lines is decreasing. Meaning the slopes are getting smaller and smaller. So say the tangent lines look like this until they level off at 0, like somewhere here, and then they become more and more negative. So looking at this graph, we see here the tangent lines are getting less steep until they get to B, where they become 0. They went from some positive slope, they keep getting smaller and smaller and smaller, until they get to 0 at B, and then the slopes start getting less and less until they reach about point C. This is the point of inflection, which is where the second derivative is 0. And this is the transition point between being the concavity of the function. So we can see here that from A to C, the function is concave down. So that means that from A to B, the function is both increasing and is concave down. While from D to E, the function is increasing, the slopes are positive, but the slopes you'll see are getting steeper and steeper, which means that the second derivative in this region is greater than 0, which means in this region, the function is concave up. We see here on this side that the slopes, they are negative, but they are becoming less steep, which means they're becoming smaller negatives. So the slope is also increasing here. So that means only from A to B is the function concave down and has a positive slope for the tangent lines. So A to B is the correct answer.